You can give your acceptance speech some other time. Well, I don't know. All right. Here's what we're doing. There is a shortened configuration. You could call it an abbreviated configuration. Some people call it like the noble gas configuration. So what you do is you're going to use the closest noble gas to the element. Hopefully you've learned in middle school that this column right here is the noble gases, the last column all the way to the right. So what we're going to do is we're just numerically going to find the most closely related noble gas. And if we do the electron configuration for Einsteinium, and I can even highlight it too to make it more visible down there at the bottom. If we do this one, the closest noble gas would be number 86. Okay, because there's nothing after that. So what we're going to do to shorten it is in brackets, not parentheses, but in brackets, square brackets. We're going to put the symbol of the noble gas that is closest. So I'm going to put radon in brackets, and then we just pick up from there. It's almost like putting like a dot, 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 you know, like a bunch of stuff happens before this, and then and we just pick up from there. We start here then. If this is number 86, then we start with number 87 as our starting place. We're in row 7. You can count down. There's 7 rows. So we're going to start with 7. We're in which block? The S's. So we're going to put 7S. And we're headed down here. So in order to get from here, we're going to go through both of the S's to 88. So we'll put S2. And then our next stop is we need to go from 89 and we need to make our way to 99. But remember, with the periodic table that we use, number 89 really should sit down here as the first of the bottom row. I'm going to do what's wrong, okay? Like, do not do the following. I've seen students do this. If this is 7S, this would be 6D, right? I've seen people do 6D1, and then they skip down here, and they'll do like 5F, and then they'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's not right. Here's part of how I know it's not right. I told you earlier that before you go on to the next sublevel, what do you have to do with the current one? I have to go all the way through it. I have to go all the way through the D's before I may go to the F's. And 1 is not all the way through. D should have 10. This is a no-no. Okay? We're not going to do that. What would be correct is doing the R in 7S2, and then we know in our mind that AC is down here in the F's. You have to take away 2 from the energy level to do the F. So that'll be 5 instead of 7, and then we count including this one. So that would be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4F, 11. Ask it.
So, the other day when you said that out loud, you didn't say that.
What do you mean?
It's like, can we do that, or do we have to write it all out?
The other day when I did it, I just started at the very beginning, and I gave you the longhand, like the entire complete configuration. What I would say is, if you're in, like, on the test, I'm going to ask you to give both. Like, I want to know that you can do a complete one, and I'm going to ask that you do a shortened one because I want to see that you can do it either way. It makes perfect sense to me that if you are doing some practice problems, like I'm going to give you in a minute, I don't want to write all that. I have no problem with you doing the shortened version, especially if it says write the abbreviated configuration. But do make sure that you can do the beginning steps. Okay, here's another thing to think about on the test when we have one, because you know we will. It doesn't make sense for me to ask you, like, what's the configuration of carbon? I mean, I want to know that you can do something hard like the configuration of Einsteinium, because if you could do that, you could do anything. So, I mean, chances are pretty good that I'm going to ask you to do something further down the periodic table in this area so that I can see that you know when to drop down one level and when to drop down 2 levels and come back up. And I'm going to ask you something more complicated. The ones that most students will screw up are these two, lanthanum and actinium, and I think we know why, because they are F1s and people will call them D1s. And 2 more that get screwed up are these 2 here, lutetium and lawrencium, because people will inadvertently call them F14 when they're really what? They're really D1s. So, you know, those are some to watch out for. Here's another thing. The rest of these in between, people will mess up. You know why? I mean, it has to do with these 2. Why will they mess these up? Yeah, so like if you're messing these up and you're calling this one F1 when it should be F2, like they'll be off by 1. So if you were going to practice for the test, I would recommend, like if you're going to try something, that you come down here and you try those 2 rows. I mean, I'm going to give you some practice ones, but like if on your own you're just going to see if you could do this, then down here would be the good place to practice. Because if you can get those right, I mean, you can get anything right. You can do all of it. They usually ask at least one of these on the final exam every year. They'll ask you for a configuration. And let me show you a couple of examples of what they'll do to screw you up with that. One of the things that they've done in the past, I love, like, this must be what it did last time. It stopped somewhere along the way. Did you notice that? It just, yeah. It did. I think the program's kind of messed up. It says flashing, which should mean that it's recording, but it looks like it's not. So, you know, I give up at times. It's like up there twice. Oh, maybe it is recording. Maybe I just captured that on the screen, so maybe I'm not completely doomed. One of the things that they have done, like as a final exam type question that's released, is they'll give you one that says something like, let me do this. Let's do chromiums for a second. They'll do 1s2, 2s2, 2p6, 3s2, 3p6. Wait, that's not what I mean to do. I'm doing it correctly and I mean to mess it up. It's hard to do it wrong. Then they'll do 3d4, 4s2. You see what I just messed up? What did I mess up? These 2? How should it be? Flip-flop those. So done properly, it should be 4s2, 3d4. So what they'll do lots of times is they'll give you an element and they'll say which of the following is the correct electron configuration. And I mean, then you have to be able to do it in order to get it. It can't be an open-ended question because we don't have those anymore. So they're not going to say write the configuration of blank. You're going to have to pick it out of a lineup. One other thing that you should be able to do is if you look at the periodic table, you should be able at this point to tell me something like this. Give me any symbol of an element that ends in P3. Give me any symbol of any element that ends in P3. So I said P. Yeah? How do we figure that out? You know that here's the P block, right? This would be P1, P2, P3. So absolutely anything from this whole column down counts as anything that ends in P3. And I like this trick because you're expected to know that. Like you're expected to know, you know, that these elements all end in P6. Everything that's in this column, they all end in P2. Everything that's right here will end in D8. I mean, you could do that with anything on the table at this point. Ready to practice? You can use your shortened, right? Let me do this too. Okay, if we were going to write the configuration for iodine, just to make sure we get it, here's iodine. Which noble gas would I use for the shortened configuration? And one person says krypton. Why not xenon? It's past it. I need to use the closest one before it. So I would put krypton. If we were doing fluorine, what's the closest one before it? Helium? And you could say that. And I'll be honest, if I was doing lithium, it seems kind of stupid to write that in brackets and then put, like 2s1. That really doesn't save me any work. I think it was actually more trouble to write the brackets. So this is really useful when you get down here in ugly land. Okay? Yep, ugly land. It's its official name. And let's see if I can make this stop now.